Good morning, and welcome to Controlled Chaos, the inevitable marriage of DevOps and security. For some of you, this may seem like a surprising marriage, but I promise you it's not, and I'll explore why today. I'm Kelly Shortridge. I'm VP of Product Strategy at Capsule8, which is an enterprise Linux protection company based in New York City. To set the tone for the talk, I'd like to invoke Peter Baelish from Game of Thrones, who said, "Chaos isn't a pit. Chaos is a ladder." Chaos can be empowering. It's an opportunity to climb higher than our current circumstances. Raise your hand if you've heard the phrase, "software is eating the world." Probably some of you. What it means is that all companies are becoming tech companies to some extent. And ICS is an exempt. Things like predictive maintenance, work management, grid edge systems are all moving to the cloud. The thing is, and what's really important, is that DevOps is furthering software's devouring of the world. So we need to understand it. The Infosec industry, as a result of this, is really at a crossroads right now, and our role is still important, but it won't be if we ignore the shift that's picking up. This will inevitably come for ICS as well, though it doesn't feel like it now, as cloud adoption furthers and as more companies move to modern infrastructure. So ultimately, either Infosec can marry DevOps and conquer the world hand in hand, or frankly, it can be rendered impotent and irrelevant. I hear countless Infosec professionals across all industries, not just ICS, denying that DevOps is the future. But ICS security also seems to be in denial of some of the benefits that modern infrastructure can bring, which I'll talk about today. This is only going to be a disservice to ICS, though, because your organizations are inevitably going to be moving their operations to modern infrastructure. So you need to start learning about DevOps. I think there's a better way that I'll be proposing you today, rather than ignoring all of this that's happening. Luckily, with ICS, you have time to prepare for this quest. The fact that you haven't, undergone the digital transformation that your peers on the IT side is actually a benefit because it allows you to practice. So, how can we harness chaos and resilience to lead to safer systems? And how can we make a marriage to DevOps last? Let's find out. So first, we'll briefly clear up what is DevOps and what its priorities are. Then we'll discuss how Infosec should actually evolve to align with DevOps. Then we'll go through the DIE triad, or DIE triad, because we all know the CIA triad just didn't cut it. Then finally, we'll cover how to apply chaos to Infosec, from mindset testing to defensive strategies. Let's start with DevOps dominion. Who here has heard that DevOps and Agile are the same things? I certainly have a lot of the time. Agile only focuses on development. It ignores the whole process. It ignores things like ops even, and certainly ignores Infosec. Importantly, DevOps isn't simply automation. It isn't just Agile, and it isn't just one tool or one piece of technology. DevOps is a specific mindset. It's a culture that embraces the unification of responsibility and accountability in the context of software delivery performance. It's a collaborative approach which proposes shared responsibilities and the dismantling of silos, and it leverages this mindset to reimagine our processes and to implement our technology better. I can promise you that when I talk to technologists, particularly people that work in ops, that they understand that Infosec is vital, especially for critical infrastructure. Infosec, as a result, can either contribute its hard-earned expertise and join DevOps, or it can stand aside as other people figure out how to secure a performant but also safe future. I personally don't think any of us here today feel comfortable with the idea that we're going to be out of the loop and that Infosec professionals will be out of the loop on ensuring that our ICS systems are kept safe in the future. We want to be a part of it. So, chaos and resilience is really the future of Infosec. So what is it? Chaos and resilience engineering is the practice of continual experimentation to ensure that unexpected failures cause minimal disruption to system performance. It uncovers systemic weaknesses, and it informs improved design and processes. Ultimately, it'll help your organization gain more confidence in its operational systems. And the ultimate business needs, which in ICS's case are almost assuredly uptime, help inform what kind of tests we want to conduct. If we embrace this future, we have to understand what DevOps' priorities actually are. So the main priority is optimizing software delivery performance to ensure that technology can actually deliver value. There's empirical evidence which shows what separates high performers from low performers in DevOps. I won't get into that today, but if you want to read more about it, check out the Accelerate State of DevOps report from this year. But an important finding from the data that I really want to highlight is that speed and stability aren't actually conflicting goals. Resilience and the ability to innovate in the face of change are actually connected. So because security is a part of resilience, it means that security and the ability to adapt to change are actually connected as well. This means ultimately that security and speeds aren't at odds either, which is critical in something like ICS, where uptime is absolutely paramount. So DevOps is continually proving its value to the business, and we can see that security, surprisingly, drives stronger DevOps outcomes. So as ICS sees increasing value from shifting its operations to the cloud, again, through things like predictive maintenance, we have to ensure that ICS also drives stronger outcomes. Otherwise, we're in for a really huge, nasty fight. So what shift does this portend for security? This leads us to the metamorphosis. For any function, conflict is going to exist when you don't have responsibility and accountability unified. The fundamental idea behind DevOps is that developers would become accountable for the operational issues that arose in the projects that they actually developed. Otherwise, you have moral hazard issues. They would no longer shove operations issues aside and claim that it was someone else's problem. So this is ultimately what DevOps unified: responsibility and accountability. Through this lens, it kind of feels logical that eventually developers will no longer view security issues as someone else's problem. Instead, they can begin accepting accountability for the security issues that arise in the projects that they develop. That would be the real DevSecOps, though I still think the term is unnecessary, and I'll honestly be a little bit mad if you use it to describe my talk. But this is the dream. I think all of you here have probably been really frustrated having to deal with and be accountable for vulnerabilities in software you didn't write and for outages in services you didn't actually provision. So hopefully this is refreshing. The resulting question is, what should Infosec's goals become in this sort of metamorphosis? An even better question might be, why should they differ from DevOps' goals? Infosec should support business goals while ensuring trustworthiness and safety. That's critical. Money will be lost in the face of outages due to some sort of security issue, especially in ICS, and operational performance will be hurt if systems are tampered with. I think this is a slightly hot take, but I think we can't really rest on the hollow excuse of this is how it's always been done. I would argue that there's kind of scant evidence that Infosec over the past few decades has actually succeeded. There isn't a lot of evidence of material progress with all of these kind of traditional views and methods. We need to try something else. Most of the progress you see is actually through things that aren't security related, like immutable and ephemeral infrastructure, which I'll talk about later. Or it's pockets of Infosec professionals, for example, with like browser and operating system hardening. So we need to think differently. This leads us to the security of chaos. The philosophy of things will fail can be naturally extended to include the philosophy of things will be pwned. This is probably familiar to you because it's the same philosophy that underpins safety systems. Failure from the resilience engineering perspective is commonly thought of as outages, when services don't operate as intended. Therefore, we can think about security failure as when security controls fail, when security controls don't operate as intended. Just as detecting a service failure early helps reduce the cost of a fix, detecting the failure of a security control early will also reduce the cost of a fix. This is where chaos engineering can help. So what are the principles of this chaotic security engineering? First, you have to expect those security controls to fail and prepare accordingly. System architecture must be designed under this assumption that controls will fail. You also should be designing your security architecture assuming users will fail, where failure is not adhering to the most secure course of action, which I think is a realistic assumption at this point. The second principle is don't try to avoid incidents. Instead, embrace your ability to respond to them. I think we can all agree that incidents aren't fully preventable. They never have been, and they probably won't be even until like the heat death of the universe. I know this is especially daunting for ICS, the idea that you have to just embrace the fact that accidents will happen or incidents will happen and prepare for them, but it's the unfortunate reality. The focus instead should be on ensuring systems can handle incidents gracefully. What are the benefits of applying this sort of chaos and resilience approach? I think in general, especially for security people, we need some sort of carrot to encourage changed behavior, and I think that'll be especially true in ICS. Luckily, there are many benefits. So I'm guessing a lot of you find it really stressful to respond to ICS security incidents. It's stressful on the IT side, and I would imagine it's even more on the ICS side. So the repeated practice of recovering from unexpected failures lowers remediation costs because teams are better prepared to handle incidents. It also reduces stress, which is important. We don't talk about it necessarily a lot in security, but stress is a huge problem as well as burnout. But it reduces stress because incidents become known problems with known processes for solving them, rather than being ruled by fear and uncertainty. Another benefit is that disruption to services is minimized, which is critical for uptime. Feedback from testing helps inform design that helps minimize potential impact. You gain more confidence in the security of your operational systems because each scenario tested helps improve the system's resilience. Another benefit from chaos engineering is that it helps foster an improved understanding of systemic risk. Chaos engineering creates continual feedback loops that help inform continual strategy. So I think it's much better than the status quo of understanding the security of components. When we focus on the component level, we miss everything at the system level. And I think in ICS, if you think about it, most incidents matter on that system level, not of the components. You ultimately care about the overall safety and security health of the system itself. How else can Infosec become more strategic then? Let's now turn to some of the core characteristics that encourage secure systems by design. This leads us to the DIE model, so it's time to die. What we need is a model promoting qualities that make systems more secure, because that would help Infosec align with DevOps. So Neil Yu, formerly of Bank of America, outlined this sort of model, known as DIE, or DIE for short. The DIE model emphasizes attributes of modern infrastructure that beget security rather than more abstract concepts like in the CIA triad, which is why I personally don't like it and imagine a lot of you don't too. D stands for distributed. It means that service outages, like a DOS, are less impactful. I stands for immutable. It means that changes are easier to detect and reverse. And E is for ephemeral. With ephemeral infrastructure, you're trying to drive the value of assets to zero. So let's go through each of these individually. Distributed infrastructure involves multiple systems that may be located in different locations, but support the same overarching goal. Think of it kind of like distributed energy resources, but with a lot fewer physical challenges. CDNs are a form of infrastructure, content delivery networks, and they directly led to the diminishment of harm by DDoS attacks over the past few years. In general, distributed infrastructure reduces the severity of service outages because it facilitates high availability, redundancy, and fault tolerance. Immutable infrastructure, the I, doesn't change after it's deployed. Data can't be stored on disks because they disappear and come back, kind of like a phoenix, as Martin Fowler puts it. If modification or updating is necessary, a standardized image with the appropriate changes is used to build a new server to replace the old one. With immutable infrastructure, servers are no longer closely held and cherished pets. They're now disposable cattle. This is the pets and cattle model, if you've heard of it. You have a base image that's validated and version controlled, so each server built from this image, if there's an issue, can be shot, so to speak. Because images are version controlled, rollbacks also become much easier, which eliminates a lot of the traditional headaches of the update process. I think Infosec overlooks a lot of the inherent security benefits of immutable infrastructure, which is frankly a shame. Configurations are performed through a standard automated deployment process rather than having engineers log in manually to configure servers. This means you can completely restrict shell access on servers, which is basically a security miracle. You want to resist the urge to continue treating your immutable infrastructure like pets, though that's what you're used to. And it can feel like a loss of control, which nobody really likes. But immutability gives infrastructure unlimited lives. Think of it like a video game. You no longer have to operate on nightmare mode, where it's game over upon death. Ephemeral infrastructure, the E, is infrastructure that has a very short lifespan. It lives only for the duration of a task before dying, unlike monoliths that can live for thousands of days. So ephemeral infrastructure actually allows for a surprising degree of control and security benefits. Infrastructure that could die at any moment is a nightmare for attackers. Attackers will always prefer systems that are online reliably for a long time, like SCADA systems. So, ephemeral infrastructure actually generates a formidable level of uncertainty for persistence. Installing a rootkit on a resource that will die within minutes is just straight up a waste of effort. It forces attackers to pivot more quickly to get to their goal, using something like in-memory attacks, which are definitely still limited to well-resourced attackers, despite whatever FUD you've heard. This means that ephemerality raises attacker cost. It raises the attacker bar by design. Because of the special nature of ICS, attackers have to perform extra recon. They have to learn the systems, perform engineering and automation, and all of that requires certainty. So because ephemerality actually introduces uncertainty constantly, you're continually disrupting the attacker's learning and all of that careful planning, which is great. As you can see, optimizing for die inherently reduces security risk, even when security isn't the stated goal. Die is about the ability to be resilient and recover in the face of unexpected threats, whether to performance or to security. I've certainly heard a lot since I joined the industry many years ago about the idea that Infosec should be included in the design phase. We have to build security by design. Die is actually the most organizationally friendly way to include security in design. Now, with that, let's go now into a phoenix rises. How can we start implementing these principles of chaos and resilience, as well as the die model? As I've said, chaos and resilience engineering embraces the idea that failure is inevitable, just as safety design espouses. Failure can be harnessed as a tool to help you prepare for incidents. It embraces the idea and ensures that when the inevitable happens, it isn't as damaging to your operations. It helps minimize that blast radius. You want to avoid complacency by using game days, and those help you practice a potentially risky scenario in a safe environment. If you don't test in a realistic environment, you won't know what the so-called complexity domino chain will do to your systems during a real incident. So game days proactively test resilience to help you establish confidence in your systems at scale. The question is, what kind of scenarios do you actually prioritize given the inevitable time and resource constraints? The answer is you want to prioritize game days based on each scenario's potential impact to your operations. Think from your customer organization's perspective. What's most important to them? What are their priorities? For ICS, your priorities are almost assuredly related to downtime, disruption or destruction, maybe leakage of data, but potentially not. Decision trees can be really valuable guides here for crafting game day scenarios. You want to start with the business priority that's at risk. For ICS, something like a cloud-based meter data management application. Then you want to brainstorm why the attacker would want to attack that asset or compromise that asset, and then how they would most easily get to that asset. It's definitely tempting to dream up elaborate scenarios, but I promise you that Mossad isn't going to send you a basket of kittens, which would be very cute, like implanted with some sort of chip that's going to conduct a sonic attack on your SCADA infrastructure. It's super unlikely. You want to determine the least cost path attackers will take to get to their goal, something more like hard-coded plain text credentials. This least cost path is the most sensible place to start your testing, which brings us to how can we start using chaos engineering for testing our systems? In general, you want to start with dumb testing before moving to fancy testing. You want to develop tests you know you can build with scenarios that you know are accessible. And I hope it goes without saying that you should start in test environments rather than messing with your SCADA systems, though I would recommend checking out the talk from yesterday by Virginia, talking about how to actually use chaos engineering in the field environments. But today, I completely understand that what I'm going to talk about isn't completely applicable to all control systems. Some systems just can't be updated or really changed by design, like some safety systems or FDA-regulated systems. But there are plenty of systems and services like predictive maintenance, analytics, and basic collaboration tools that are being deployed in the cloud or on modern infrastructure. So you have time to start experimenting with those before you inevitably have to start with your field-based systems. Let's start with how to control chaos with distributed infrastructure. Distributed is closely aligned to the concept of availability. Luckily, most of the existing repertoire of chaos engineering tools addresses availability, which means we can test the resilience of distributed infrastructure too with many of these. The most famous of these is probably Chaos Monkey by Netflix, which injects random instance failures to test their application's resilience. There are also availability testing tools for other sort of cloud systems, like Azure has a native fault analysis service. There are ones for AWS, Kubernetes, Docker, so forth. Infosec teams can therefore adopt these tools, and in their game days, you only have to slightly modify the source of failure so that availability failure is due to an attacker rather than some sort of random bug. But distributed infrastructure also offers a really fun opportunity to bamboozle attackers through multi-region services. If you have load balancing, you can rapidly redeploy their services and change the composition of how they look and where they're set up. You can actually shuffle IP blocks and make them different on a regular basis, and you can do so without penalty because it's reasonably easy to move resources across availability zones. The net result of this, which is awesome, is that you're changing the lateral movement game for attackers. Next up is how we control chaos with immutable infrastructure. With the continuous delivery necessary to support the deployment of immutable infrastructure, you also gain continuous defense. You're creating a volatile environment with continually moving parts, which makes it difficult for attackers to discern how they can actually get to their goal. Immutable systems will restrict the ability for users to write or modify the system in any way. Because of this, most immutable systems will allow you to create rules like, if there's ever a write to disk, crash the node. These sorts of rules force attackers, as I said before, to stay in memory, which hopefully makes them cry. Despite all the vendor FUD, again, this means you're raising the attacker cost to ensure that only sophisticated attackers can actually compromise you. For example, consider a case where an organization has implemented this sort of rule on their Docker containers. Now, you're an attacker with Metasploit interpreter running and a web shell running. You see a passwords.txt, which obviously is a juicy file, so you try to access it, but then the container immediately explodes on you. A Docker image can be built with this sort of bamboozle layer. It won't affect the other team's layers, and it should only involve simple ongoing maintenance by the security team. This bamboozle layer can contain a bunch of garbage, like a home/users/passwords.txt that's filled with garbage values to give it a realistic file size. These enticing garbage files can be marked as unreadable as bait. Attackers will try to mark them as writable, which triggers your automatic shutdown. It's pretty cool. Attackers will be forced to repersist. Your DevOps team will almost assuredly be notified due to an error rate spike or some sort of latency issue. This kind of bamboozling will ruin attackers' days, which I personally think makes defense a lot more fun. Now imagine if you can ensure your edge devices were self-healing. As Brian Owen said here on stage last year, what if they could go back to a known good state after they're attacked? That's exactly what designing for immutable infrastructure enables. Ensuring immutability involves testing for unauthorized changes, then ensuring they're being detected and reversed. So a very simple test involves injecting attempts at writing to disk. It's talked about a bit. It's a very easy one with which to start. Finally, how do we control chaos with ephemeral infrastructure? Again, ephemerality's goal is to drive the value of assets to zero. So testing ephemerality is largely anchored around testing for statelessness, reverse uptime, and perhaps surprisingly, throughput. Most security bugs are state-related. If you get rid of the state, you get rid of the bugs. It reduces the ability for attackers to persist on systems, and stateless apps help drive the value of data to zero based on their design. They don't rely on persistent storage, which makes the window of opportunity for attackers to seize data really minimal. Reverse uptime is a fun metric that measures the amount of time a host has been online, but from the perspective of more time adds security risk. Minimizing the amount of time a resource runs supports ephemerality, so you want to work with your engineering teams to tear down old hosts and reimage them. Again, this will only give fleeting windows of opportunity for attackers to persist. Retrograding is an interesting general testing strategy for ephemerality. Older versions of software, as you probably know, are more likely to have known vulnerabilities, so attackers will try to downgrade you when they can in order to facilitate their attacks. So a test for this is you want to inject old versions of libraries, containers, and other components into your development pipeline, then make sure that you're detecting them. Tests for ephemerality can also imply concepts from toll fraud to throughput, which is maybe a more surprising one. Cloud systems, in a really weird way, can be thought of as a utility. And billing isn't traditionally monitored by security teams, but it can become a security signal. If you maintain daily billing for cloud resources, you shouldn't see massive spikes in costs. But an attacker exfiltrating terabytes of data out of an S3 bucket or running a crypto miner will absolutely cause billing spikes. This is especially obvious if hourly or more temporally granular billing is used. So you can test this with your own crypto miner and see if you're actually detecting and responding to that sort of attack. I would recommend that if you do mine Bitcoin from your crypto miner, use it to pay back the cloud bill. Don't retire on an island. I'm not liable. Please don't blame me. So, in conclusion, DevOps is the new engine of business, and that's going to be true for ICS as well. It's inevitable. Infosec has a chance to marry DevOps before it's too late, and it won't secure a future by playing a staunch gatekeeper because organizations are just too incentivized to modernize at this point. Chaos and resilience represent a natural home for Infosec, and it represents its future. It's a future that can be fun, innovative, and meaningful, which I think we all know aren't words that are commonly associated with Infosec. Enterprise security, to survive in this modern world, must unify responsibility and accountability, because that is the only way to truly marry DevOps. ICS is already one foot in the cloud through things like Office 365, predictive maintenance, grid edge systems, and storage systems. So it's better for you to become a leader rather than a gatekeeper. You want to be an enabler rather than just a doer. If SCADA as a service becomes a reality, you really want to have spent time practicing all this chaos engineering before it's too late, because I think for all of our sakes, we need to be prepared for SCADA as a service, which I still find kind of terrifying. Giving up control can feel scary, but resilience offers a beacon of hope. It's the hope that Infosec can finally be innovative and fuel performant and safe operations too, can now be an engine of the business as well, rather than kind of pushed aside as the department of no. I hope the recommendations that I imparted to you today help you go forth and live a long, happy, and fulfilling marriage with DevOps. To close, remember Nietzsche's words. You must have chaos within you to give birth to a dancing star. In order for Infosec to achieve greatness, you must harness chaos and marry DevOps. Thank you very much.